You would have definitely wondered about a few questions in connection with electron gain enthalpy. What is electron gain enthalpy? Why is it called electron affinity? Why is electron gain enthalpy negative? What is meant by less negative and more negative value of electron gain enthalpy? When does this become a positive value? You would definitely have thought about these questions. In this video, we will find the answers for all these questions and clear doubts. Hello everybody, I am Anandavalli. Welcome to this new video from Guidancee Education channel. We are continuing class 11 chemistry, classification of elements and periodicity of properties. Periodic properties part 10. Fourth periodic property, electron gain enthalpy. We will discuss definition, representation, unit of electron gain enthalpy, successive electron gain enthalpy. Answers for all the questions introduced in the introductory part of the video will be answered. So watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now. Subscriptions are totally free. Press the bell button and all button so that you get intimated as soon as new videos are posted. Thank you very much. Come, let us start the class. Fourth periodic property, electron gain enthalpy. Enthalpy, as you already know, it is a change in energy. Here, it is the change in energy when electron is accepted by an atom. When an atom gains electron, it becomes negatively charged, that is anion. We have already discussed ionization enthalpy, wherein the atom loses electron and becomes a cation by absorbing energy. In the case of alkali metals, when they lose electron, they become more stable than the neutral atom. Let us take the example of sodium atomic number 11 in order to explain the reason for the stability of the cation when compared with the neutral atom. The electron configuration of sodium atom is 1s2, 2s2, 2p6 and 3s1. 3s is the outermost shell. When this electron is lost from the outermost shell, it becomes sodium ion with one positive charge. Then the electron configuration becomes 1s2, 2s2, 2p6. The total number of electrons becomes equal to 10. But the number of protons is equal to 11, so atomic number does not change. Now, after losing one electron, the number of electrons become equal to that present in neon. So, by losing one electron, sodium atom acquires the electronic configuration of neon, which is a noble gas or an inert gas with the outermost shell having 8 electrons. That is octet structure, which is stable. That is the reason for the stability of the cation when compared with its neutral atom. So some elements have the tendency to lose electron and become more stable. Tendency to lose electrons is governed by the ionization enthalpy. We have discussed all this in the previous video. Now let us see electron gain enthalpy and how it offers stability. But before we continue, if you have not subscribed my channel yet, please subscribe it now. Thank you very much. We will first define electron gain enthalpy. It is much the same way as we defined ionization enthalpy. It is the energy released from an isolated neutral gaseous atom when it accepts an electron to become a negatively charged ion, that is anion, also in the gaseous state. It is represented as delta EGH. Say for example, chlorine, atomic number 17 plus 1 electron becomes chlorine 17 but with one negative charge, Cl negative. This chloride ion is more stable than chlorine neutral atom. So when one electron is received, it releases some energy, which is the electron gain enthalpy. Then the total number of electrons becomes 17 plus 1 equal to 18. Now perhaps you are able to say why the chloride ion is more stable than the neutral atom, because it attains the electron configuration of argon, the noble gas. Electron configuration of chlorine atom is 1s2, 2s2, 2p6, 3s2 and 3p5. Electron configuration of the chloride ion: 1s2, 2s2, 2p6, 3s2 and 3p6. This is also the electron configuration of argon. During this process, the chlorine atom loses energy. Chlorine atom has more energy, chloride ion has less energy. This difference in the energy is released as electron gain enthalpy. I hope you have understood. So metals absorb energy, lose electrons and gain the electron structure of the preceding noble gas and become more stable. The difference in the energy is the ionization enthalpy, whereas non-metals gain electrons and lose energy and gain the electrons configuration of the succeeding noble gas. The difference in the energy is electron gain enthalpy. Energy is released. The change in energy is represented as delta electron gain enthalpy, delta EGH. Now let us make the general representation of the process. X gaseous plus electron gives X negative ion and change in enthalpy, which is electron gain enthalpy. This is how the whole process is represented. X is not the real symbol. Higher the energy released, higher the electron gain enthalpy. Please see the representation of the process. Greater this value, that is delta EGH, greater will be the electron gain enthalpy. Generally, when the first electron is added to the atom and when it becomes the anion, energy is released. Therefore, a negative sign precedes this value. That is, it is written as negative delta EGH. The unit of electron gain enthalpy is the same as that of ionization enthalpy, that is equal to kilojoules per mole. Nature of the process: it can be either exothermic or endothermic. During exothermic process, energy is released. During endothermic process, energy is absorbed. First electron gain enthalpy is always exothermic. Second electron gain enthalpy is always endothermic. The definition refers to first electron gain enthalpy. This will become more clear when we talk about successive electron gain enthalpy. Successive electron gain enthalpy, that is, electron gain enthalpy for adding electrons one by one. First electron gain enthalpy, second electron gain enthalpy, and so on. First electron gain enthalpy is always negative. Energy is released. It is an exothermic process. The second electron gain enthalpy is positive value because energy has to be supplied. It is an endothermic process. We have already seen when the first electron is added to the neutral atom, it becomes an anion. When the second electron is added, it is added to the anion. So the anion repels further electron addition. So the second electron gain enthalpy becomes positive. That is, energy has to be supplied so that the anion can take in more electrons. For example, the first electron gain enthalpy for oxygen is negative 141 kilojoules per mole. That much energy is released. The process is exothermic. Ionization enthalpy, the value is positive 780 kilojoules per mole. That is, energy is absorbed. It is an endothermic process. O negative becomes O2 negative. The electron configuration for O2 minus will be 1s2, 2s2, 2p6. Atomic number is 8, but the total number of electrons become 10, which is equal to the number of electrons present in neon, the succeeding inert gas. So that is why O2 minus is more stable than oxygen neutral atom. For sulfur, the first electron gain enthalpy is negative 200 kilojoules per mole. First electron gain enthalpy is negative there also. Energy is released. The second electron gain enthalpy for sulfur is positive 590 kilojoules per mole. Energy is absorbed. From this you can understand, in general, the first electron gain enthalpy is always negative and the succeeding electron gain enthalpy is positive. So, electron gain enthalpy can be either negative or positive. But when we refer to electron gain enthalpy, we mean the first electron gain enthalpy that is always negative. Now consider the first electron gain enthalpy for oxygen and sulfur. We can easily understand that the electron gain enthalpy for sulfur is more than that of oxygen. For sulfur, the value is more negative, and for oxygen, it is less negative. It means sulfur gives out more energy when it receives one electron, and oxygen gives out comparatively less amount of energy when it gains one electron. Electron gain enthalpy is also known by the term electron affinity. The sign of electron affinity is opposite to that of electron gain enthalpy. Compare the first electron gain enthalpy of oxygen with that of sulfur. The electron gain enthalpy of sulfur is more negative than that of oxygen. In terms of electron affinity, sulfur has more affinity for electron than oxygen. So, sulfur is more reactive than oxygen. So, the more negative value of electron gain enthalpy, the greater the reactivity. Electron affinity means affinity for electron. That is readiness to accept electron. Now you have the answers for all the questions asked in the introductory part of this video. Hope this video was of great use to you. If you think it is useful, do share it with your friends, like the video, and if you have not yet subscribed my channel, do subscribe and support. Also leave your feedbacks and comments in the comment box below. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video. Till then, bye. Take care.